Well, hi everyone. I'm here with Dr. Nathaniel Jeanson for part 5 in the series, The New History of the Human Race. We're much more closely related than we think. He's rewriting human history. Well, secular human history he's rewriting. He's not rewriting biblical human history, rewriting secular human history and showing how the true history is really biblical human history. And today, the topic for episode 5 is the secret to human history. And you're going to talk about mitochondrial DNA. Actually, I want to tell people, Dr. Jeanson, right from the start, you're going to talk about some genetics and DNA and mitochondrial DNA. But listen, even if you don't understand some of the technical details, you will get the picture. It will blow your mind because you're going to talk about mitochondrial Eve, mitochondrial DNA. Just tell us, 2-sentence summary, what we're going to find, and then launch away.
We're going to look at a clock, a genetic clock that marks off just 6,000 years of history and bears the echo not only of creation, but also of the flood. So there's some profound signatures here of exactly what the Bible talks about.
So in genetics, in the mitochondrial DNA, there's actually a signature where you can see the flood.
Yes, there's hints of this, and we'll see that the steps we're going to take in this episode get us very close to the smoking gun, which will open up all of human history for us to examine in great detail.
Wow. And sort of looking ahead through your notes, I shouldn't tell everyone this, but seems to me you're going to show in genetics, there's actually evidence of three distinct groupings, which would correspond maybe to Ham, Shem, and Japheth's wives. Would that be right?
Yes, even the evolutionists recognize 3 major groupings in our mitochondrial DNA genetic family tree. And these are ancient groupings, and they bear strong resemblance to what we'd expect from the history laid out in Genesis.
Wow, everyone is in for an exciting time. Okay, launch away. Let's hear this.
Always an adventure trying to share the screen. Here we go. Okay. So episode 5, New History of the Human Race. Let's step back just for a moment to get our bearings as to the big picture of what we're striving for and charging towards. We want to know, what are the relationships among people groups alive today? We all look so different, act different, have different cultures, yet there are connections among us. We've rightly said as creationists for many years that Babel is key to understanding this. What we haven't looked at in as much detail until now is what happened after Babel. And part of the reason we haven't looked at that until now is we haven't had the genetic tools to do so. These are questions I hadn't even considered until just the past few years. And the discoveries we've made, my colleagues and I, have been remarkable. We're going to see connections among us, among people groups alive today. And we'll also get at that fascinating question of what is the connection between us and the ancient cultures. I've taken for granted that the ancient pharaohs must have been the ancestors of modern Egyptians, the ancient Greeks, the ancestors of modern Greeks. I'm half German. I don't know of any Germans who claim the Persians, the Egyptians, the Greeks, the Romans as their ancestors, because they're Germans. Why should they? Yet I've come to discover that this sort of assumption is wrong, and we're beginning to uncover why this is the case. And just again to whet people's appetite for what we will eventually be covering as we discover the tools that'll lead us to these conclusions, we're going to find out that so-called black, white people exist. We're all various shades of brown. So I use this in the common sense. There are Caucasian people wandering around who've had dark-skinned ancestors for thousands of years and they don't know it. We're going to discover that most Europeans, again, Caucasians, think they've had ancestors in Europe for thousands of years. We're going to discover most Europeans are of recent Asian ancestry in a way that, again, no one saw coming. We're also going to see that the European nationalities disappear within a few hundred years. And this is not to downplay nationalistic pride. I'm particularly sympathetic to this when the World Cup comes around and Germany plays, and especially if Germany wins, being of half German ancestry. What we're going to discover at the genetic level, this sort of nationalistic identity doesn't have a genetic basis in a short amount of time going back in history. Thinking of history elsewhere in the globe, we're going to see that the Americas were resettled, not just by Europeans after Columbus, but by another people group before Columbus, and this of course raises the question of who are the originals. We're going to go back to the most ancient history and try to uncover what happened right after Babel, where people groups went, what do we make of the Neanderthals, and the mainstream scientific view that they seem to be primitive. We're going to discover that they weren't primitive, but survivors likely of ancient catastrophes. And my overall goal in all of this is not just to give people a new history, but a new sense for who they are, who we are, so we can marvel at our stories, the stories of those we love, in a way we've never dreamed of before. And this is something I had never dreamed of until we started cracking this open just in the last few years. This is information you won't get anywhere else. And just to recap some of the previous episodes, because this information all begins to converge in short order. These clues all come together. We've looked at the history of human population growth and seen that just a few hundred years ago, there are a lot fewer somebodies back then than alive today. We all come from somebody, but if there are fewer somebodies in the past, well, then you have to start connecting people more quickly than you think. We've done the math of human family tree growth. So I come from 2 people. My parents each have 2 ancestors. So 2, 4, 8, 16, on back you go. It's a form of exponential growth. It multiplies every generation. But if you go back 800, 1,000 years, you have billions of ancestors, something which cannot possibly be true. And the only way you can solve this little problem is by forcing the family trees of your ancestors, your parents, to connect. So your parents are more related to each other than you think. Your spouse is more related to you than you think. And if you apply this principle globally, you soon discover that there must have been racial, so-called racial or ethnic changes in the recent past. We've looked at the genetics of how this could occur, and we've seen it's very easy for it to occur. We've also looked at the math of human reproductive population growth and seen that a small minority of people can come into a country, have just a slight difference, a slightly faster reproductive rate, and end up basically taking it over, being the ancestors of the majority of people in fairly short order. We've discovered that Caucasian Europe could have had dark-skinned ancestors in the recent past, and the majority of Europe could be the descendants of Africans in the recent past. Only genetics can tell us whether or not this is true. What we want to do today then is look at the secret to human history. This is a secret that mainstream scientists aren't aware of, and in fact, most of them don't want this to be true. But this resistance to the secret is hiding from us the true history of the human race. And if you recall from last episode, episode 4, we ended by discussing some of the common genetic tests that we might be tempted to consult to answer the question of how many of us have had African ancestors in the recent past. Maybe some of you have gone to Family Tree DNA, 23andMe, Ancestry DNA, any one of these major popular commercial genetic testing companies. You pay $100, they'll give you a readout, a report of you're this percent German, this percent British. That's what they tell you. And many of us want to know, well, sure, we know we're European. We know typically that our ancestors hailed from this country or that country in Europe, but we want to know the exceptions. We want to know, if you're Caucasian, do I have a Native American ancestor? Do I have an African ancestor? If you're of African descent, you might want to know, do I have a light-skinned ancestor? You can substitute any ethnicity you want to. The problem we discovered is that every generation, that ancestral signal gets diluted by half. So if you're like me and the majority of your family tree is Caucasians and you want to know if there's another ethnicity in your family tree, well, that person, that, let's say, theoretical dark-skinned ancestor would have likely married light-skinned people, so that every generation, the genetic signal of the offspring gets diluted by half. So that man shown in this family tree is 100% African at the DNA level, but his descendants then would be 50% African, his grandchildren 25%, next generation 12%, making me 6.25%. And we've also discussed that for technical reasons, anything below 10% is likely not reliable. We don't have clean genetic signals below 10% given the success or failure of the current technology. So in other words, you pay $100 and you really learn a little more than what you probably already know. That's not to criticize these genetic testing companies. That's just the limits of technology. And to put it in family tree form, really the problem is you've got genetic signals from both sides of your family tree having to be compressed into you, and all that signal gets diluted until very little is left except for the recent generations. So what can we do to solve this problem? Isn't there any other genetic tool by which we can go back beyond just a few generations into the deeper past? Where can we find this? So we're going to get into the weeds just a little bit. We're always going to come up for air, and I'm always going to step back and say, okay, what is the key takeaway from what we just discussed? So to look for a clue as to a more ancient genetic signal, let's crack open the cell. The cell is a very complex structure. Its complexity itself is a testimony to design. We are still learning lessons about the way the cell does things, and we could spend a long time talking about it. We quickly run out of good analogies for how the cell does things because the level of information compression, it just boggles the mind. We humans, smart as we are, have yet to replicate the full level of engineering and design that we see here, which, if you reflect on it, must mean that a superintelligence, God himself, must be behind the design and engineering of the cell. Well, we're going to try to simplify this complex structure and focus only on those parts of the cell that have DNA to see if there's something within the cell that maybe doesn't come from both parents, maybe only from one parent. So typically, let's say this is an egg cell. We're going to focus on the primary place through which DNA is inherited. So when we talk about the DNA from both parents, the structure that we're talking about primarily is the nucleus, this sphere. There's a sphere within this sphere that's just a subset of the DNA, but this orange sphere is where the DNA is located if you were to crack open the cell and look at it under the microscope. If you did the same thing for sperm, the dad's contribution, it has a structure like this. You can see in purple there is a nucleus. That's really all that matters for the purposes of this immediate discussion. So at fertilization, life begins, sperm meets egg. The entire sperm, though, does not enter the egg. The tail does not. It's only the head that has that nucleus. So this is the biological basis, just very briefly there, for 99% of our DNA. That's why we look like a mix of both of our parents. Both parents, through sperm and egg, and the DNA contained in each, are what contribute to the features that make us. My facial features are a mix of my German mother and American dad. Well, is there anything else in the cell that could illuminate deeper history? Within the egg cell, there is a little-known second source of DNA. It's the mitochondria here, and there's several of them shown here in orange again. Sperm has these as well. They're sort of in the tail compartment here, again in a golden color, the mitochondria. However, when sperm meets egg, like I said before, the entire sperm does not enter, it's only the head. And so practically what that means is the nuclear DNA, in purple there for the sperm, and the large sphere for the egg, the nuclear DNA comes from both parents, but the mitochondrial DNA, because most of the time the sperm does not contribute this, there may be some rare exceptions, because of the cell biology of fertilization, mitochondrial DNA comes only from mom. And you probably haven't heard about this much because it represents less than 1% of our DNA. However, all that technical detail is so that we understand why the mitochondrial DNA can act as, in theory, a tool to understand the deeper past. The problem with nuclear DNA is it comes from both parents, so that genetic signal gets diluted. It's the vast majority of our DNA, and you can see here, graphically well depicted here, that the two streams in blue get more narrow and more narrow. That ancestral signal has to be compressed into you and me. Well, with mitochondrial DNA, it just goes straight down through the maternal line. I have the mitochondrial DNA of my mother. My 4 children have the mitochondrial DNA of my wife. Dad's DNA does not dilute the signal of mom. So this, in theory then, might be a solution to our little problem of getting deeper into the past beyond a few generations. It's less than 1% of our DNA, but maybe that's enough now to understand more deeply who we came from and who we are. So to go back to this diagram, we said the problem for DNA inherited from both parents is every generation another parent adds their own DNA and it dilutes the ancestral signal beyond recognition in just a few generations. Well, what I just mentioned is that mitochondrial DNA does not get diluted, so it keeps getting passed on, keeps getting passed on. You can see from this diagram it has its own limitations. So my mitochondrial DNA is going to tell me the ancestry straight back through my maternal line, and the other side of my family tree doesn't contribute a mitochondrial DNA signal. So it only tells you about one side of the family tree. However, that one side can take you, in theory, into the deeper past. Now, what I've shown here is not an entirely accurate diagram, and it would not be useful if this is the way things were. I've put 100% transmission. The 100% of the signal is transmitted each generation. And if that were true, if the signal was passed on, the mitochondrial DNA was copied in egg and passed on from mother to offspring perfectly every generation, every single person around the globe would have the identical mitochondrial DNA sequence. There'd be no differences. There'd be no history. How could you have any history if everything's the same? Well, that's not the entire reality. That's an oversimplification. What happens on a regular basis is that when mom copies the DNA, the progenitors to the egg cell copy that mitochondrial DNA, every so often a mistake happens. The curse happened. We live in a fallen world. Things do not operate perfectly. And this fact of our fallen world means now there's a clock, basically, at the mitochondrial DNA level, at the microscopic level. There is a clock that exists that ticks off how many generations pass. So every so often there's a difference that's going to arise. So you can compare one generation to previous generations and you'll see differences. And those differences then, just like a clock marks the passage of time, this marks the passage of generations. So more accurately,
Dr. Jeanson, let me ask you a question. So the further back you go, there'll be fewer mutations?
There'll be fewer mutations and more differences.
And more differences, okay.
So if you and I have a lot of mitochondrial DNA in common, we must have had a recent ancestor. And if you and I have very different mitochondrial DNA, that means our ancestor must be in the much deeper past. There's been more ticks of the clock.
Yep.
So more accurately than in this family tree, it's not 100% transmission. It drops off ever so slightly every several generations. So we're still 99% identical at the DNA level. There are a few differences because of the curse, because the world is no longer the perfect creation that God created. He's cursed it, made it operate less than what it was originally designed to be as punishment, and to spur us to hope for heaven when God will make all things new. And one of the consequences then is this DNA clock. And the number of differences represent the number of steps, basically, in a family tree. So if there are many steps in the family tree between me and you, that means we have an ancestor in the distant past. If there's just a few steps, if we're cousins, third cousins, we have an ancestor in the recent past, and DNA reflects that history. So the key takeaway here, the two key takeaways so far, is that mitochondrial DNA, in theory, solves the problem we discovered in the last episode. The problem is DNA signals get diluted if you have both parents contributing. Well, we've discovered if you look at cells under the microscope, there's a section of our DNA that gets passed on solely through one parent, in this case, mom, and that transmission process is imperfect, and so we have this built-in clock-like behavior. Well, clocks can be wound backwards in time, and so in theory, perhaps we could wind the DNA clock backwards to find the ancestor of us all. If we could get mitochondrial DNA from everyone around the globe and find the most distant point, perhaps, that connects all of us, that would take us back to the beginning. So let's bring in something from episode 2. We mentioned that if we try to trace the number of our ancestors backwards in time, I come from two parents, we each come from two parents themselves, and they come from two parents, you get this multiplication each generation. You can't do this indefinitely because you'll have billions, trillions of ancestors. That's not possible. It doesn't fit history. At some point, these branches have to start connecting. Well, what I want to do now is take that a step further. This is true not just going back 1,000 years. This is true if you go back even further in history. The world population keeps getting smaller the further back you go in time, so you have to keep connecting these lineages. And at some point, you reach the beginning. This is true for mitochondrial DNA through the maternal line, the father's side, the maternal side, both sides. Eventually, you reach the beginning. And again, you can see this with DNA because every so often there are mistakes that occur. The more DNA differences that separate two people, the further you have to go back in the past to connect them. The fewer the DNA differences that connect them, the more recent they have a common ancestor. Well, let's find that deep point at which we all branch off, which might tell us that first maternal ancestor. You may have heard the term Mitochondrial Eve. I want to step back for a moment and talk about her briefly, because it's tempting, given the name and the obvious biblical connotations, it's tempting to say, well, could this be the ancestor? Could this be the biblical Eve? And some old earth creationists have wanted to go this direction. What I want you to see here, though, from the evolutionary literature, I'm just going to take some data from this particular paper published 20 years ago, one of the early papers, but a significant one, and the data are still accurate and representative of what's out there. I want to show you what the evolutionists mean by this and to see how it differs from what the Bible's talking about. So here's the family tree that results from analyzing mitochondrial DNA from 50 plus people around the globe. We're going to zoom in here momentarily to look at the individuals. If you're used to thinking of family trees as maybe you at the bottom with your siblings, and then the next level up is your parents and their siblings, the next level up is grandparents, and time moves from the present to the past, from bottom to top. There's a similar principle that applies here, but you just have to rotate it in your mind 90 degrees. In this case, time moves not from bottom to top, but from left to right. So the present day is here, and the deep history is back here. The present is on the right, the deep history is on the left. And so to go backwards in time, you just trace the branches backwards in time to here. Now let's zoom in and see how the evolutionists draw this family tree of humanity. And notice one of the things that pops up first here at the bottom part of the screen. You can see it's not a human, it's a chimpanzee. The evolutionists determined that the beginning of the human family tree is where the chimpanzee mitochondrial DNA sequence branches off. So what they've done here is not only take the mitochondrial DNA from people around the globe and try to figure out the number of differences and similarities among us, they've also gotten the chimpanzee mitochondrial DNA, looked at the differences among us and said, okay, we know we have a common ancestor with the chimpanzee. We know that the human race began after we split off from the chimpanzee. So let's determine that the beginning of the human race is where that branch point is. So you can immediately see as a creationist, there's already some major differences between the so-called mitochondrial Eve of the evolutionist and the Eve of the Bible. They say mitochondrial Eve is back here, the beginning, where we connect to the chimpanzee. Obviously, the Bible says Adam and Eve were created separate from all the animals. They're made in the image of God. So she can't possibly be the biblical Eve. So let's now move on up through the tree to see who the humans are. Over here you have San individuals. That's an African tribe. All the names here connecting to the purple branches, and then eventually we'll see here the green branches. They're all African tribal groups. The San people are in Southwest Africa. They have cliques as part of their language, a very different sort of language than English. Mabudi are some of the Pygmies, as well as the Biakas. There's a diversity here of African tribal groups. That's the point that I'm trying to show you. Then if you move on up the tree, you can see the rest of the African groups here in green. Yorubas are from Nigeria, and on it goes. Now, let me back up a slide here and show you that the leftmost part of the tree, the beginning, where we branch out from chimpanzee, first branches off into these African groups. That's part of the reason evolutionists say Eve arose in Africa. So number one, they say she has a common ancestor with the chimpanzee. And because of that, because the Africans branch off first, therefore she's also an African, not necessarily a descendant of Noah and his family in the Middle East. So there's a second point of difference. And you can see as we move on up the tree later on, as time moves from left to right, it's later on that these non-African people groups begin to branch off. So in orange, you've got Japanese, Siberians, the Waorani and the Warao people of South America, Australian Aborigines, Papua New Guineans, Chinese. If you move on even higher, some of the blue branches up here, you can see the Europeans branching off as well, English, French, there's Germans, you can see Central Asians like the Uzbekistanis, more people from Papua New Guinea, Australian Aborigines, and so on. So that's the big picture view of what the evolutionists mean when they say mitochondrial Eve. They say common ancestor of the chimpanzee, branching off in Africa first, and they also stretch this entire family tree over hundreds of thousands of years. 200,000 years, some would say 300,000 years. The point is they do not go back just 6,000 years. And something this diagram does not show, but that's also important and has become a prominent discussion point in the last few years, they will say, evolutionists will say, there never was just two people. You might say, well, the family tree goes back to one point. Yes, and for technical reasons we don't have time to get into, they say that point represents one of many individuals alive at that time. They reject the idea of Adam and Eve. So when you hear the term mitochondrial Eve used by evolutionists, there are all sorts of points that say she looks nothing like what the Bible is describing. The time scale is different, the ancestry is different, the geography is different. There's so many points of disagreement. She's not the biblical Eve. Well, what can we do then? It seems like we had a potential tool here, mitochondrial DNA coming through just one parent. It avoids the problem of dilution. It acts like a clock. Perhaps we can step back through history, wind the clock back to the beginning. Yet the evolutionists talk about something very different than the Bible. Well, let's take away some of these evolutionary assumptions and just try to look at this tree through the lens free of evolutionary assumptions. So what I've done here is I've taken those 53 individuals and added several hundred more. You can't actually see the names of the people here in this diagram. You might say, this looks very different. I don't see the beginning. Yes, that's the point. We're going to say, where is the beginning? We're going to ask the question, where is the beginning, if we leave chimpanzee out of the discussion? This is just displaying these hundreds of humans from around the globe and asking the question, where does the beginning most naturally appear to reside? So once again, the tips of each of these branches here represent individuals. And these lines then represent branches on the family tree. Well, if these tips represent modern individuals, then time must move from the tips backwards, from here backwards, from here backwards. And you might notice very quickly there seems to be a natural center to this diagram, as if this might be the most ancient time period. You will also notice that there's naturally three major groupings, three major ancient groupings. There's a more recent grouping right here, but in terms of ancient groupings, here they are. And this is not something I'm making up or manipulating to try to prove a creationist point. This is something the evolutionists have talked about for many years. They recognize these three major groupings. They don't think much of it because they have put the origin of the human race back here in Africa. These are African branches. This is where the chimpanzee branches off. And because they're viewing it only through the lens of we must have apes in our ancestors and our family tree, they say, well, this must be the beginning. Well, if you remove that assumption from this discussion, suddenly your focus shifts to these branches over here. Now let's bring in the scriptures and see how we might make sense of this through the lens of the Bible.
Hey, Dr. Jeanson, before we go on, do the evolutionists give particular names to those three groupings?
They just have letters, so they'll name these the L, M, and N. Those are three alphabetical letters. They'll call them haplogroups. Those are just the technical terms, but you can find that in the literature, and they've been in the literature for quite some time. So what I've just said is not something they would dispute. They would again dispute calling that the beginning because they insist, well, you've got to go where the chimpanzee branches off. And I'm saying, hold on, let's just look at humans. Where is the natural place your eye goes to? Where's the natural place you might call the beginning? And lo and behold, there's these three groups.
And it's, again, this is an incredible example of if you have the wrong foundation and the wrong set of glasses on, the wrong worldview, you're not going to see the evidence the right way. And if you put on a different set of glasses, it all makes sense.
Yes, and in today's very polarized discussion, people talk about, well, you can have fake news, you can have real news, but you can't have fake facts. You got to have the real facts. Well, oftentimes in origins discussion, what is fact and what is interpretation becomes blurred. And so the beginning of the human race, the beginning of the human family tree, the evolutionists might call a fact when, in fact, it's an inference and a combination of multiple evolutionary assumptions. The facts are, there are three major groupings, and they form a natural center if you leave chimpanzee out of the discussion. So we have a factual basis for looking at the family tree very differently. And especially when we start to think of what the scriptures say and about our ancestry. Yes, we begin with Eve, but the Bible says the world population was reduced to 8, just under 2,000 years later, about 1,700 years later at the time of the flood, down to 8 people, 4 men, 4 women, Noah, his wife, the 3 boys, Shem, Ham, and Japheth, and their wives. And Genesis 9 says these are the only ancestors, the immediate ancestors of all of us. The sons of Noah who went out of the ark, Genesis chapter 9, Shem, Ham, and Japheth. These were the sons of Noah. From these, the whole earth was repopulated. So there's no one else we can invoke to think about who our ancestors were. Well, we want to know what this means for mitochondrial DNA. Where did those 3 boys get their mitochondrial DNA? Well, we've just mentioned that this comes through mom. So they must have gotten their mitochondrial DNA from Mrs. Noah, whatever her name was. What happened to their mitochondrial DNA, though? What happened to the mitochondrial DNA of these 3 boys? Well, DNA comes through mom, through the maternal line, so it stopped. Mrs. Noah's lineage, as far as we know, stopped with these 3 boys. Instead, our mitochondrial DNA lineages trace back to their 3 wives, whoever they were. Scripture is silent on their identity. I'm suspicious that they were not daughters of Noah and Mrs. Noah, and they may have in fact been 3 separate lineages who last shared a common ancestor with Eve. So, is it any surprise then that there are 3 major groupings, ancient groupings, in our human mitochondrial DNA family tree? They are present there. I call them ancient because they're part of this natural seeming bullseye center. The longer branches here in Africa may very well be due to the fact that the clock ticks a little faster in the African lineage. No one's tested that yet. That's actually a testable prediction. Another discussion for another day. But the existence of these 3 groups at very near the beginning of the family tree seems like a very strong hint of what the Bible is talking about. How interesting. But what about the time scale? What about the time scale for mitochondrial Eve? What we've seen here is we might have the mitochondrial flood ancestors so far, if we look at the human mitochondrial DNA family tree. What about the fact that the evolutionists stretch out the entire tree over 200,000 years? Now, I do not have a problem with how the evolutionists have arranged the branches. We've just seen that there's a problem with where they pick as the beginning point. Everyone has to pick a beginning point. They start with first assuming chimpanzee ancestry, and then they use that to inform their beginning point. So their beginning is already bound up in the assumption of evolution. Without invoking that, there's multiple places you could invoke, and we've seen that there's strong evidence that the beginning might be near that bullseye point, and the hint that of these 3 groupings might be the 3 ladies at the time of the flood. Well, how long ago was this? We know scripturally this was just 4,500 years ago. Where do evolutionists get this idea of 200,000 years? Well, this does not come from genetics itself. This comes from looking at the geologic time scale for the evolution of humanity and then applying it to genetics. Well, we just mentioned a few minutes ago that mitochondrial DNA acts like a clock. Every so often there's mistakes that are made. Could we use the genetic data to try to arrive at a conclusion for when the beginning was? And in fact, you can do this sort of experiment. You can get mothers and daughters, grandmothers and granddaughters, get the mitochondrial DNA from each of them, and then count the number of differences. It's really pretty straightforward. And then it tells you how fast or slow this mitochondrial DNA copying process, mistake process, occurs. Is it the slow ticking of what evolutionists invoke, or is it pretty fast, more like the ticking of a stopwatch? How far back in history did this mitochondrial DNA ancestor live? Well, let's look at what the evolutionists said. One of the earliest studies to try to measure this was just a few decades ago. In 1997, the commentary on this was written in Science magazine in early 1998. And Ann Gibbons, the author, said researchers have calculated that mitochondrial Eve, that's the evolutionary Eve that we just mentioned, the woman whose mtDNA or mitochondrial DNA was ancestral to that in all living people, lived 100,000 to 200,000 years ago in Africa. So that sentence is referring to the application of evolutionary geology to the genetic family tree we just discussed. Now, this is what she goes on to say, using the new mitochondrial DNA clock. So she's referring now to one of the first attempts to count the number of differences between mothers and daughters, grandmothers and granddaughters. Using the new information, she would be a mere 6,000 years old. Well, doesn't that sound familiar? No one thinks that's the case. Well, why does no one think that's the case in mainstream science? Because it disagrees with evolution. Now, I've published several papers taking all the data that's been accumulated over the last several decades and showing that the original conclusion, mitochondrial Eve living just 6,000 years ago, still holds true. This is something you can directly infer from a straightforward interpretation of the genetic evidence. So not only does the Bible indicate that Eve, mitochondrial Eve, lived 6,000 years ago, looking at straightforward science, there she is. There's the echo. Now, our bigger question,
Dr. Jeanson, let me ask you a question. How do they get that 6,000 years? I mean, if we all go back to Noah's sons' wives, and then they then go back to Eve, we don't have mitochondrial DNA from the flood back to Eve.
So it gets into a little bit of a technical discussion. One of the wives of Noah's sons might actually have a sequence pretty close to hers, but that's a question we may never be able to answer, because the way we determine the DNA differences and similarities is all comparative. So how many differences make up the human family tree? Well, you determine that simply by comparing DNA from a German to DNA from an Ethiopian to DNA from a Chinese, and so forth. And we would need pre-flood people to do that.
Right. So you're looking at the differences you see now, you're saying it calculates to 6,000 years worth of differences.
Yes, and 6,000 years is just sort of a round number. 4,500 years is compatible with that too. There's always a measure of statistical error. It's usually anywhere from 4,000 to 10,000 years. It falls right in that window. I use 6,000 years. That's what this lady said explicitly in her article. That's using sort of the average rate that they calculated.
In other words, there's a few thousand years of differences, not hundreds of thousands, just a few thousand.
Exactly. You go back a few thousand years, and it's right in line with the biblical window.
Okay.
And there's, if we want to get really precise, the primary units by which you measure this are not directly in terms of years. When you do your calculation as to when Eve lived using genetics, you measure the number of differences per generation. And so how many generations do we go, and do we need to go up from the present back to Eve? Well, you look at Genesis 5, and people lived a long time. It's a male genealogy, but I presume the females also lived a long time. Pre-flood, it's a very different world. So you have a few generations over 1,700 years, whereas nowadays people have children around age 25 or 30. So even trying to take the present data and extrapolate back in time, there's a little bit of uncertainty just in terms of how long were the generations. Yes, it might be one mistake every 25 years now, because mom was 25 when she gave birth to her daughter, but they may have been 100 years old when they gave birth to children pre-flood and so forth. So that calculation that they just did makes some assumptions about the generation time at which ladies gave birth in the generations prior to ours, and we don't have that historical data. You just have to take a guess at it, a reasonable approximation, and you come up with that number. And of course, there's a little bit of wiggle room because of that uncertainty. What I want to do now is convert that number. So this leads right into what we just discussed, leads right into this, and put it in perhaps a even more tangible sense and apply it to the question of who we came from. So we know from Genesis 5, 10 generations from Adam to the flood. That's the paternal side. My presumption is the maternal side is going to be something similar. The flood is about 4,500 years ago, according to the biblical time scale. And here's our estimate that we were just discussing. If we assume, just to make the calculation simple, that all ladies were 25 years old when they gave birth over the past 4,500 years, that translates to 180 generations from the flood until now. 180 plus 10 is 190 generations from creation until now, which means there's less than 200 generations that have passed from creation until now, and even fewer if you go from the flood until now. And these are just round number estimates, and it could be even fewer, because you look at Abraham and Sarah is much older than 25 when she gives birth. It seems to be an odd, a miraculous exception to the general rule. But nonetheless, the ages of the patriarchs are different typically than what we see now. And of course, there's ebbs and flows all throughout history, as there are ebbs and flows in different cultures today. Some marry earlier, some marry later. My point is, as we're thinking about human history, especially post-flood, post-Babel history, we're going from nearly 8 billion people alive today back to just 8 people total in 200 generations or less. All those 8 billion branches on the family tree of humanity alive today have to collapse back to 8 in just 200 generations. With that small window of time, with a family tree that's much shorter and shallower than we think, there must be a lot more connections among us than we're used to thinking. Now, we're not quite yet at the tool we need to dig into the precise details of this. This is just a few technical comments to tee up why we have to keep searching. But the mitochondrial DNA clock, mtDNA is just the abbreviation, ticks once every 5 to 10 generations. So if one generation is 25 years, that means a tick of the clock happens only once every several hundred years. So if you want to know details of what happened in the last 200 years, you might not see these precise details. If you want to know when did this people group separate from this people group, it's going to be a little bit harder to be very precise with the mitochondrial DNA clock. It tells you the big picture. Yes, it's all within a few thousand years, but getting to more precision, let's say we use our mitochondrial DNA sequences to find out that Ken and I have a common maternal ancestor in 500 AD. Well, because the statistical noise associated with this and some of the scientific uncertainty, it might be 500 years, or it could be 1500 AD, it could be 500 BC. So maybe the Renaissance or the time of the Greeks. There's enough noise here that level of uncertainty doesn't tell you a whole lot about the details of human history. It tells you that the big picture family tree of humanity is much shorter than we think. Even as young Earth creationists, sure, 6,000 years. But you translate that to the number of generations and you say, oh, wow, that means we've got to condense all these branches to 8 and ultimately then to 2 at Adam and Eve in 200 generations or less. That makes the connections happen quickly, and it's going to yield a whole lot of surprises. And to find the tool that'll get us to that detail, we're going to keep looking, and I hope our viewers will join us next time for more on the new history of the human race.
Dr. Jeanson, this is just absolutely fascinating. So, as you said, we could see the signature in the genetics of the mitochondrial DNA of these 3 groupings that make sense to correspond to the wives of Ham, Shem, and Japheth. And for the next part, tomorrow night, part 6 is the smoking gun of human history, and you're going to look at the Y chromosome in the male, and you're going to show that you can see a signature of what?
We're going to see, once again, it goes back to a beginning. We're going to see it fits a 6,000 year. Actually, in this case, we can see it fits a 4,500 year time scale very specifically. And we're going to find, and we're going to look for the history of human population growth. This is really the hockey stick shaped curve from episode 1 that should be present in our Y chromosome. It's a testable prediction. This is what the evolutionists are always demanding of young Earth creationists. We're going to test that prediction to see if we can see that hockey stick shape, something that no one's going to be looking for and should not exist in our DNA if our ancestry goes back hundreds of thousands of years.
So you're going to see the signature of the flood, is what you're saying.
Signature of the flood and beyond. We're going to see the history of humanity that even the evolutionists recognize. For the last 3,000 years, 1000 BC onward, there's little disagreement between evolutionists and creationists. They accept, okay, yeah, now they accept there's a King David, they accept Persia, they accept the existence of Babylonian Empire, Egypt, Rome, Greece, so forth. Well, that's going to leave an echo, a signature in our DNA. And if we view our DNA through the lens of 6,000 years, through 4,500 years, we should see that stamped all throughout our DNA. The evolutionists expect it to be virtually undetectable because they stretch that family tree over such a long period of time. The last 3,000 years is just this tiny fraction, so why would you even look for it? It's almost going to be lost in statistical noise. Well, the last 3,000 years of human history is the major fraction of 4,500 years, so it should be stamped here and stamped here and stamped here. All of that should be showing up in our DNA. And if we can see it show up in our DNA, then we can say, okay, what does the tree tell us about human history that we never thought we'd see before? And now we can begin to interrogate the question of who exactly did we come from? And there's going to be all sorts of surprises that pop out that I never would have dreamed about.
Wow, this is absolutely fascinating. And I look forward to that. So people to know, you can get the previous parts 1 to 4, and then this one will be added to on a playlist on the Answers in Genesis YouTube channel. Number 6 tomorrow night. So look forward to number 6, the smoking gun of human history. Thanks, Dr. Jeanson.
Thank you.